Hello peeps, Drugget here. Welcome back to another Starmade tutorial. Today we are talking about dock generators. That's coming up. Now, the less trickier part for me was to figure out what I would like to build and actually build it. The more trickier part would be to make a tutorial fitting for pretty much any docked reactor. But let me try. So what I did first was like, yeah, sure, let's build the most effective power reactor out there ever. So I went like, I wanted light as a feather, and for each actually block you use, I want it to be the highest efficiency ever, right? We ended up with around 180 power per block used every second. Let's start at a different angle. What we want to do when we build power reactors, we want to first, of course, have a docker. Then we need to decide on a system to transfer the power. I personally prefer a power supply beam and slaved a cannon computer, because the other option would be power supply beam and a big power storage, right? Thing with the cannon computer is it makes this thing so rapidly firing that we need very little storage. And the amount of storage probably would make this thing bigger than it has to be otherwise. So I just opted for this thing because it's also it's easier to stabilize such a reactor compared to the other option. Now the next step I wanted to do, because I wanted it to be the most efficient, yada yada yada, I figured out how many groups of power I wanted. And I went like, come on, let's do this with 4 groups. And then I figured out what would be the most effective lengths of those groups. And I came up with 394 blocks for each of those power groups. Because if we go with 394 lengths of each of those, we are at the maximum efficiency wise. So this much power divided by these many blocks results in a efficiency of 954.0118. So each of our power blocks creates 954, this number per second. Okay? Why do I we could go smaller, right? But then we would result in just this number, and you see 011, well, that's less, right? So maybe try the other direction then, like getting bigger. And also we notice, well, this is smaller as well as our 0.118 thing here. 394 blocks when you are dealing with 4 groups. That's the ideal measurement. How did I figure that out? Well, trial and error, basically. Now that we know how much power we generate, we need a way to transfer the power, right? Actually, I ended up with 3000 of these and slaved 3000 of those. We are generating 1.5 million power per second, and this thing does not drain our energy, right? So I figured out 3k blocks each works out pretty well, does the job, right? Also, I figured this out by trial and error. So now that I knew those numbers, I went like, okay, now I have to put this in the smallest available shape. I noticed then that I would have to put the power in such a pattern using all the axes of that thing, and then I could make it 5 wide, 4 high, stuff like that. This is also trial and error, right? Basically, you are doing lots of steps behind each other and rebuilding this thing over and over and over to finally get it to a point where you would say, okay, now this is ideal, this is what I want to work with. And not everybody watching this tutorial later is going to try to build the most effective thing like I did here, because more people are going to, well, I want to work with more groups to have it more cubish sized so I could fit it in shorter ships, yada yada yada. Or some people are not even going for the most effective build, they just want to know how to build power reactors in general. First thing is an automatic firing mechanism. So let's cover this first. We have our rail docker here. Let's put an activation module right behind it. It's necessary that those touch each other, okay? Then we take this and route it into a end. And from the end we go into a delay. And from the delay we go into a NOT. Then let's charge this NOT by activating and deactivating this delay module. And from the NOT we route back to the end. Okay, this little setup we did here will, as soon as we dock to something, start pulsing, right? See this end blinking all the time? So then we could take the signal from the end and link this to our computer in order to fire our beams in regular intervals, okay? Now let's just quickly show you how I did the power setup here. This works basically as such. So by doing this, I shortened our 394 long thing we had before to 387. We now have to fill this up with modules. Don't forget to mark the one and make this the current output where you want the beam to come out. So I want this right behind this rail docker, so here. And then we basically fill up the entire thing like such. Also doing the same thing with our cannons. Now, because I knew that I need 3000 of both the power supply beams and the others, I could now just look up the entity structure here and check for power supply beams, and we see we got 2697, so we need 303 of those. There we go. And now let's check the, how's it called, antimatter cannon system. These are 306. Now if we try to actually fire this, we notice that we need 90k each single tick. Now problem is our power storage is just 50k right now. So we need to add at least 40k power storage. Gladly we have some space back here. And now comes the thing, we should put even more in here because stabilizing the power generator. What does stabilizing mean? Well, the server has lag, right? So let's say it enters a game tick, and this game tick goes like, oh, by the way, you should check that our generator is providing power to its ship. Since the game might also have to render explosions and stuff like that and whatnot, or the server in general just has lag, it might go like, well, I don't have time to do this in this tick, so let's move this on to the next tick. And then the server does this, just, you know, trying to keep up with the general flow of the game. And so you might up ending like half a second, then the server comes to the conclusion of, alright, so now I have to calculate all the power transfer ticks of the last half second. How much power do we have? Is the power storage filled enough to do like 5 ticks which are accumulated, and then it does this at once. Basically, what we are trying to do, we are trying to add headroom so we are able to prevent this dock power generator from, in case of lag, basically run into a power outage when the game tries to, you know, transfer all the power which has accumulated in one point of time. So, as you can see right now, we have 249k of power storage. This means this is more than 2 ticks, more than tenths of a second. Yeah, not really much on really laggy servers. So in this case, I just would recommend, you know, reduce up to 50 blocks of both and add more power storage. But for this dock generator, it works. I am assuming it should also do a good deal on a server. That's where I ended up. Now, if you in general have questions about how to figure out those values, as I said, it's mostly trial and error, or in this case actually also calculating, which then times 2 means we are ending up with transferring 1,440,000 each second. Those 1,440,000 divided by 7,756 blocks. And quickly, 7,756 blocks means each of our blocks is worth 185.662 power each second. So quite an effective system. I just hope by building this thing and, leading you guys through this process, you actually are able to figure out the information you need for building your power reactors. If not, please leave questions in the comments. Yeah, that's it for now. If you have in general questions about power, I have other tutorials out there. In general, you should check out this playlist. You might find lots of useful Starmade stuff in there. Thanks for watching. Please leave a like if you liked it, and see you guys next time. Bye.